Alright, so, guys, remind me again, how do minerals form? What is the process by which minerals form? We have a lot of titles to talk about here. Last term. I want you to look at this image. Down here at the bottom is the magma chamber. You can again see where the magma has chewed its way through the rock. You guys see that over here? Okay. So this is kind of what we're talking about before. The magma comes through the rock. Minerals form and redeposit new rock for cooling. Look at the magma chamber. This is a pluton magma. Actually, all these are plutons. This is a batholith. Up here is a lactolith. Batholith. So I want you to look at this image that I have here. It's a little grainy, but it gets the point across. Give me your definition of a batholith. What do you notice in that image? What does it look like? Speak up. Austin, try again.
Like upside down bathtub.
That's a great way of looking at it. That's good. What else does it look like? What is it similar to? The two layers that you see, Brandon, that are the two dark gray layers. Okay. And a lot of similarities. So this way, they kind of look like different layers, alternating layers. And that will sometimes happen in this situation. All of batholith two separate layers. Is solidified. Rather, like you said, it's two different rocks that have been forged together. So what you have is this dark gray rock. And that might be. Imagine that at one time was solid rock. 100 to 300. And then at another point in time, this new rock forced its way inside. Huge. And this isn't just a solid rock thing. How do you take solid rock and infuse another type of rock? What has to take your batholiths are extremely large, and it's basically a solidified magma chamber. How could you possibly take solid rock and another piece of solid rock and force one into the other? Here are stocks. What does a stock look like to you? Holy cow, AJ, your light bulb just turned on. That's exactly how it works. If you can imagine it, you have magma that literally comes through and melts the rock. And literally slowly bores its way through the rock layer. Okay, yep. It's actually old volcano. So you had this. Remember we were talking about the vent going up. So look at this volcano. This hot magma is literally melting through the rock layer. Okay, so that's what a stock is. It's just a little cavity, remnant. And then when that magma cools, what's left over? Of the volcano. The new rock inside. That is a lactolith is just a small, call that magmatic intrusions of solidified magma. So you want to think of it like, basically the way I think of it, batholith, big giant bathtub of solidified rock. Okay? Lactolith would be like the sink. Basically, it's still pretty large, but it's not as big as the batholith. And then cools inside the cavity. By the way, this suffix, LITH, all over the place, means rock. How many guys have ever been driving around? So anytime you see that LITH in science, usually and you see this big boulder. Has ever heard of somebody's yard? It's a really dark boulder. But then they start getting these lithic meaning stone, white lines that just kind of new stone era, new rock era across the rock. So Neolithic. Okay, then we have two other things I want to talk about: a sill and a dike. That is a window sills. What can you tell me about example? What shape of the intrusions? That white rectangle line that you see is actually quartz, and that's straight. And really, in this case, in the small cracks like that, it's actually from heated water. Sills are exactly that. But basically, it's where the intrusion goes in, melts through the rock itself, and then redeposits the quartz in the cavity. Okay, so those are examples of magmatic intrusions.
Parallel
the
and
rock
so
layers.
a lot of
That's
times
what
we
you
think
need
if
to
it's on a
remember.
small
The
scale,
sill
if it's on a small local scale,
is
it's usually
parallel
going to be through hydrothermal.
to the rock layer.
That's heated water. And when it happens on a grand scale, often over
Basically, it's just where
miles of area,
and
we call that
intrusion that
a
is
magmatic
intrusion.
Now, collectively,
But what do you know about the dike?
we have all types of magmatic intrusions. We call these
Vertical.
plutons. And
Okay, so plutons is the collective name.
This is the best one I
of
could find.
all
The dike is
magmatic
vertical.
intrusions.
It just simply is not parallel to the layers. It cuts across the layers.
And so here are some images
So the dike
of
cuts
various
across layers.
types of plutons. So, again,
And the one
take
thing I
a
really
look
want you guys
at
to remember
this
is
image.
right
This
here.
is three-dimensional.
In that image, you can clearly see the land.
We look at this
Green grass
diagram.
right here.
What we
Which
see
is
here is just
definitely
this two-dimensional
different type
thing.
of rock. And also,
As
you
this
have
goes
very
across
thin
back
split
through
from
the
a
whole
new
block of
jutting
land.
up through that.
So when we look at this
Okay,
sill,
that's the type
it's
of
parallel
magmatic
to the
intrusion.
layers.
It simply
but then
doesn't
remember,
fit.
this goes
with the
all the way
territory.
through.
So that's why they're
Going.
really easy to identify.
If you look at this one on the left,
Huge
it's
rectangular
flat desert
hills.
all the way around it,
and all of a sudden there's this little
three-dimensional.
pop-up of rock.
So you get these
That doesn't occur in the
thick
natural
layers.
That again
Going
has to
through the
happen
land
through
of the
some type of
magmatic
fault
intrusions. Same thing with the lactolith. We see that in two dimensionals, but really, well, in this one here on the right, three dimensions.
This is what we would call a dike.
So it's really kind of a big
And
pool
we'll explain
taking up
here
the
in a minute
entire
what dikes
space.
look like.
Okay, so let's
Last
look at a
thing
couple
over
pictures
here.
here.
So you can kind of see these sheets.
You guys ever heard of
popping
Devil's
up
Tower
as
in
you go
Wyoming?
across the valley floor.
Okay.
So again,
That's an
also
example
pop-up
of
right
a
here.
stock.
Those are, because they can be very
large
large
or
or
somewhat small. Sometimes you get a leftover neck of a
And
volcano. That's
tell
called
us
stock.
volcanic rocks. If you look closely at Devil's Tower,
And I will show you guys a picture of that here in a minute.
what do you notice about the rock?
So these are all different. Again,
Yeah, they're
this is
actually
actually a really
hollow
great image here on the
rocks.
left.
Okay. You can
See
see
oddly
the gray,
enough, Devil's Tower
or
is
the
actually
light gray areas. That's the normal rock, and then you have
See, that's
the
antler
basaltic. A new rock deposited. Again, that's a magmatic.
And you guys ever heard
cutting
of
itself
the
the Giant's Causeway? That's something we're looking at. We've not seen that
Okay.
before. Look that one out. Giant's
So
Causeway.
let's kind of go back to this. look at
That's
this
in
kind of a more simple
Ireland.
diagram.
That's really kind of cool.
And then we also have a dike sitting here between the two rock layers. Okay. Now, the images I wanted to show you guys from that Allie actually took on her trip to Arizona. This is actually really cool. While flying over the Southwest, you can see all types of awesome geology. It'll probably take me a while for this next page to load. Now, it doesn't really, kind of got to look at this, kind of tilt your head a little bit. But you guys see the two stocks? Okay, so that's actually what they look like. That's a true stock from the air. So like I said, you have this flat plane, and then all of a sudden you get this jutting up of rock. Okay, that's a perfect example of stocks that happen all around us. And in fact, you guys see this right here. You guys see that? I had to look at this one a little closer. This actually follows this line and then curves back in like this. That is an example of a dike. Okay, so it's basically this big sheet of lava that has cooled. So it's actually, like I said, this is why I hated leaving Arizona. There's so much geology out there. I had to come back here to glacial country. Bleh. I know. So, yeah. And then this image right here, you can kind of see a little bit of another intrusion sitting right here. So that's basically it for today. I mean, we're just looking at intrusions. Your homework tonight is going to be identifying types of intrusions and some of the characteristics of them. Okay?